This one's going to upset the purists.
And now it's time for the latest exciting episode of Doz's Television Workshop.
Hello and welcome back to Doz's Television Workshop, where today we're taking a look at this beautiful Sony TA-4650 from the mid to late 70s with a little bit of a checkered past. Let's get into it. This is the wonderful Sony integrated stereo amplifier TA-4650 VFET. This was a technology developed by Sony using some quite trick transistors, bleeding edge at the time, if you will. These date, I think it started manufacture sometime in 1976. It's quite a rare thing. Produces about 35 watts per channel. And this one is very sick. Complete cards on the table here. Ian turned up late last week from Geneva. And he bought a number of bits and pieces for me to take a look at. So I went through them. And sadly, this has got a terminal fault. So anyway, Ian went away. You know, he said, oh, well, I don't know how much you paid for it. But yeah, he said, if it's not going to be repairable, there's no point in sort of carrying on with it. So I said, yep, fair enough. Anyway, I sort of scratched my head a little bit and thought, I could do something with that. So here we are. This is not going to be a video for the purist. I'm probably going to upset a lot of people. Have a little look down in the comments below. But yeah, so what I've done is I've purchased it from Ian because it sort of matches my current hi-fi fetish. I've got a very nice turntable that actually needs a service. So we'll get that on the bench in the next few weeks and have a look at that. Anyway, the turntable matches this. So I think it will be quite a pretty addition. Very well thought of, except for this one. So let's get it in bits and yeah, have a look and see why I've condemned it. So like I say, I was in here late last week, so I know exactly what to expect. 4 machine head screws, looking a bit M4, holding the cover on to reveal the wonders of 70s Sony. Yeah, so as we can see, we've got quite a substantial power supply. We've got all our phono bits sort of very traditionally on the front panel here. Let's just angle that camera a bit so we can have a better look. There we go. Capacitors look all right, probably. There's a couple of shrunk jackets on the output stage, which is this board here. But yeah, it's a thing of beauty. Now, you'll notice there's a screw missing from here, and there are a lot of screws on this that were loose. So it's been got at some stage in its life. I think Ian might have said he bought it in France. So yeah, anyway, one other thing concerns me, and not quite sure if you're getting this on the camera, but you can see these little drive transistors here. They're supposed to have those beads up against them, and they're not. That's for temperature compensation, and they're not up against them. So yeah, it's seen a bit of action in its time. We've got a couple of resistors burned out over here. So yeah, I had my suspicions as soon as I saw it. But yeah, this has got a terminal failure. So I'm just going to power it up and I'll show you what I found out fairly rapidly that's causing the problem. So I'm just going to pop a bit of mains on, switch it on. We have a green indicator light, but if you listen carefully, we had no speaker protection relay click, which is a bad sign. So if I just fetch myself a ground, move around to volts DC, I'll use one of the top case grounds, move around to volts DC, and on the bus bars that are going to each VFET, as you can see, I'm getting precious close to no volts. And that's because that screw's missing. So I'm just going to turn off for a second and bridge that ground back to the chassis with a clip lead. And that'll restore our HT. You will hear again there is no click from the speaker protection relay. And if now we measure the voltage on the FETs, is that going to be horribly glary, or can you read that? I think we can read that. We've got 48 volts on that one, so that's encouraging. Trouble is, we've also got 48 volts on that one, and it's the same with the other two. Yeah, where's our minus 48 volts? We go over to the power supply. We have got plus 48 volts and minus 48 volts, as we should have. So one half of our power supply is missing from the output stage, and I'll tell you now, the output VFETs have failed. Now, before you all get in the comments and start saying, oh yes, they're easily available, I've seen them on eBay and AliExpress. What you've seen on eBay and AliExpress are fakes. Make no bones in that at all. I'll show you what they are. If we just remove the output stage. By the way, if you want to poke round down here, you'll also find there's 48 volts on the speaker outputs. And that's why the protection relay is not activating. There are 4 screws to remove the large heatsink that the FETs are on. Remember, this is only a 35 watt amplifier. If we just take that out, you will see underneath the VFETs themselves. They've clearly been replaced at some time in the past. It is a 2SJ18 and a 2SK60, and they are utterly unobtainium. About 12 years ago, 11 or 12 years ago, you could still buy them out of Japan. There was some new old stock kicking around, and then they disappeared. And anything you see now are fakes. Every transistor is to be presumed to be a fake until proven innocent. And there's got another problem with them as well. Those that purport to be genuine and look convincing are £100 each. I need 4. That's 200 quid, and I'm probably buying fakes. Ones that are definitely shady seem to be about 50 quid each. I'm not going to risk either of those options. And this is where the purists are going to get upset. Now, a lot of people have sort of worked on a solution to fit different FETs into this amplifier. It's not an easy task at all. And that is because a FET has 3 terminals, just like any transistor, a gate, a source, and a drain. And the voltage between the source and the gate is critical. It's called VGS, voltage gate source. And these transistors in here have a huge VGS, something that no transistor manufactured today gets anywhere near. Therefore, to get this biased up correctly and sounding right is a mammoth task. The bias on these, I think, is something like 75 volts. It's huge. It's unique and somewhat bizarre. So, what have I bought it for? I like the styling of it. Hopefully the preamp will be alright. I haven't checked it yet, but it's just a preamp. There are some unusual FETs in the preamp, but I think we can find equivalents for any of them if they have failed. They're unlikely. It's small signal stuff, so we should be good. There's also a chunk of bipolar stuff in there as well. So that's where it's at. Now, what am I going to do? Well, I'm going to take this out and fit a Class D module. Not a Chinese one, not one of those nasty cheap ones that can't drive an output impedance properly. What I would really like to do is fit a Hypex in there, but they don't really want to supply DIYers anymore. I think I can find a grey one, but again, do I want to be buying grey stock? And it also gives me a slight power supply problem. So what I'm going to do is go to Profusion and buy an ice power module. Right, it's the following day, and my ice power module has arrived already from the wonderful people at Profusion. Next day delivery, very prompt indeed. Yeah, I'll just quickly take you through the connections on here. We've got mains coming in there. This is a DC output designed to feed other amplifier modules. We won't be using that. This is control output here, and input as well. We can drop the amplifier into standby and a few other things. I don't think I'm going to be using that, although the idea is sort of mooted that I should put the protection relay on there. But I don't think it's necessary because the module itself is self-protecting. But I will, of course, have to make something that overrides that relay, or at least powers it up. Out of these two here, we've got our speakers, and this is our audio input here. So the other thing we've got to take note is that is going to get hot, but not hot. They recommend it's normally bolted down to the chassis or onto a separate heatsink. So we need to engineer that. And to that end, what I'm thinking is we'll utilise the original Sony heatsink. So just for now, I'm going to remove the PCB from the heatsink and sort of reutilise it is the idea. Yeah, I can't get in there to get that out. I'm not going to disconnect the heatsink as yet because I need to know where that relay output actually goes. So, right, let's just expose this side and remove these damaged VFETs. You'll notice none of these screws are tight, by the way. Like I said, I don't think I'm the first to have been here. Yep, the heatsink now just comes away, and yeah, as you can see, nothing fits. So my plan is actually to take this heatsink down to my local machine shop and get them to take the top of it off and make it flat with this center rib here. And I'm going to nick down there and see if they can do that for me, and if they can, that's obviously going to bolt straight into the hole that we had left behind. I've then got somehow to mount that on there. It does give me some problems actually because it's not wide enough. I wonder if I've got a heatsink that would be bigger and flatter and avoid going to the machine shop. I'm going to go and have a look in my junk drawer. Right, I had a look in my box of heat sinks and I found one that was close but not quite, so I've bitten the bullet. I'm only going to be doing this once, so I've ordered this one from Farnell, which, as you can see, is a pretty good fit for our amplifier module. And also, it's a pretty good fit in here. Let me just move the old module out of the way, the output stage. I am going to have to liberate this wiring harness very slightly there. But as you can see, that's going to sit in the bottom of the amplifier quite nicely. So that's what we're going with. I could shorten that, I suppose, but I'm going to try and keep the amount of metalwork I've got to do to an absolute bare minimum. If you're a long-time follower of this channel, since the website days, you will know that my metalworking skills are legendary, and not for the good reasons. So the next job is to fit this to the heatsink. The base is notched out, so we can fit M3 screws according to the book, and we need 6, and they're all a little bit staggered. So I don't know whether just to try and pin some holes in the right place or make myself a jig. I think I'm half tempted to make myself a jig because I could get it sort of spot on then. So I'm going to go and 3D print something, I think, that I can slot over the heatsink, and it'll get it all nice and central, and then I can drill through. So yeah, that's going to take a little bit of designing. So yeah, I'm going to go and do that. Okay, so the 3D printer has finished, and I've 3D printed myself this thing with holes in. It's got a lip on one end, and the holes conveniently, by design, line up with the holes in the amplifier chassis, like that. So the plan is this just fits on here, and it's a tight fit, but it will go. And this is going to be my drilling guide, so my metalwork is not totally shocking. That's the plan. Crikey, that is a good fit. I wanted it tight, so there we go. Yeah, wow. The vagaries of 3D printing, I think. It'll go. That's it. Okay. Right. So now it's time to drill the holes. I've got a 2.5mm drill in the end of here. That should be the tapping size for M3. So just locate the drill in the hole and go for it. Just in between the ribs there. Not ideal, but well, it is what it is. Need to be a little bit careful when tapping the hole for M3. Let's get on with the next one. Excellent. That appears to have gone quite well. Yeah, quite pleased with that. That actually looks all right. Yeah, look at that. I've got some really well-aligned holes for once in my life. Thanks to the power of 3D printing and my little jig. very pleased with that. You can hear the 3D printer running in the background, by the way. That's because I'm making some brackets as a bit of a trial. Not sure if I'm going to persist with those as yet. We got a little bit of a burr on there, so I'm just going to get my countersinking tool and just take that burr off. Much improved. Right, out with my M3 bits and pieces. Put the drill up out of the way for a minute. And in here we have an M3 tap. And I'm going to do something naughty and do it with the drill. Just slowly, slowly. And just add a spot of lube. This is just 3-in-1 oil, but it might do us some favours, mightn't it? Just a drop in each hole. Obviously, this would have all been better done on a pillar drill or a drill press if you're in the States, but I haven't got one. So hand drill it was, but it all feels okay. So yeah. So what I need now is either some thermal paste, or I have actually got some of that phase change material, so I'm wondering if I cut a piece of that out and yeah, fit that, whether that would make a good job or not. So I'm just gonna have a look at that. Where is it? This is weird. This feels ice cold to the touch because of its thermal business. So I'm thinking if we just cut a piece of that out and stick it down, that'll give us great thermal conductivity between the amplifier and the heatsink. I'm just going to mark that up with a Sharpie, if I can find my Sharpie. That'll do. And I think I could just cut this out with a pair of scissors. Right, we're going to need some M3 fasteners. I think let's just give that a bit of a clean. Some IPA. Not that this is going to get massively hot. This heatsink is really over the top. They recommend you just bolt it to the side of your case. So I think we've gone over and above here. But unless it's valves, electronics don't like being hot. So let's give it every chance. I'm going to peel that layer off. It's like, it smells like plasticine. It's weird stuff. Very weird stuff. There we go. Let me get this around the right way. Okay, that's in pretty good shape. And find some suitable fixings in the M3 box to nail it down. Cool, that's all tightened down. It's reasonably straight. I'm pleased as punch with that. You can see some of this phase changing malarkey is starting to ooze out the end here. So I think what I'm going to do is, before we actually fit this onto its brackets, if the brackets work, I'm not entirely convinced yet, then yeah, I will just tighten it down again just to make sure it's in good contact with that heatsink. But no, that's a good job, I think. That one ain't the straightest screw in the world, I have to say, but it's in there. That's all that matters. Yeah. Right, so I'm going to put that to one side for a moment and turn my attention to one, having a quick clear up, and then have a look at removing the original module. Okay, so back to removing this lot. These three wires are our signal input, which we're going to want to retain. These four here are, I believe, left, right, ground and mute output. Mute drives the relay circuit. And the rest over here is power supply. And of course that burned up resistor. So this lot, it's going to be redundant. So I'm just going to, in fact, I'm going to snip it all off. So if we ever want to reinstate it, I can see where all the original colours are. There we go. Just so a close-up of that, you can see that power supply feed resistor there is well and truly burned up. Shame, but it is what it is. Now clearly I need to put some heat shrink over there just to insulate these. These I'm not worried about because they're never going to do anything anymore, and it's on an output side. I do need to disconnect from speaker A all the wiring there. That is speaker A, it is the top one. So I'm going to desolder these four and then make up a new loom to go in there. But the next thing I think to do is to get these brackets in and see if I can mount the new amplifier module in there. And my 3D printer's just thrown an error, so I've got to restart the print. Never mind. Right, it's now several weeks later and I'm back on the VFET. Other things got in the way, and as usual my particular jobs fell to the bottom of the pile. I 3D printed these two brackets, which to be honest was a little bit silly. The idea was going to go one on there and one on there and hold the module into the bottom of the amplifier in the existing holes, except for how do you get the screws in because they're underneath the heatsink. So the 3D printer is just working on a revision 2, which we'll see if that works. So those can go in the recycling. I've got to make up some leads for the amplifier, and to that I bought some receptacles and crimps. Mostly from Farnell, a couple from eBay because Farnell were out of stock. I think I've got the right crimp tool. So yeah, I want one for mains, two here for speakers, and this is our audio in, and I believe I've got the right thing here for the audio. Let me just check, otherwise I need to make an order again. Yeah, no, that's the right thing, the look of it. That's where audio goes in, and I'm going to attempt to use the Sony's original lead for that. So that can stay in there for now. Right, first things first, mains, and I'll probably use this for the speakers as well. This is, yeah, just a bit of mains lead I've got kicking about. It is brand fire new, which is nice. So just square that off. Strip the outer insulation to a suitable length. Perfect. And strip the inner. Where are my crimps? Slightly bigger ones for these speaker and power receptacles. Just want to have a look at sort of what length I've got to strip. Not very much by the look of it. This cable's good for 3 amps, so 700 or 800 watts, so that'll be absolutely fine. Obviously, if you're in the US, you might want some thicker stuff. Okay, let's load the crimp into my crimping tool. That way round. You can tell I don't do this often. Not aided and abetted by my tremor at all today. About there, I reckon. Let's have a look. See how that's come out. Stuck in the mandrel. Bit of an inspection. Nice. No, that's great. Good. Yeah, that looks excellent. So I need to refer to the datasheet for this module and find out which is live and neutral. So I'm just going to do that. So pin 1, which is this one up here, is neutral. So connector goes around that way, that goes around that way. There we go, that's our mains power located in there, like in that. So I'm just going to get enough to hang myself with this lead and cut that off. Right, now it's just to make up the speaker cables. I've got this 16 AWG wire that hopefully will fit in the same receptacle, probably just, and we're going to go with that for the speakers. I have to say that's very much on the limit of what that crimp will take, but let's give myself again plenty of wire there, and make another. Right, audio input. Now, it's not as straightforward as just connecting this up. because we need to add in some 100 ohm resistors, because the input to the ICE power module is actually balanced. So there is a bit in the data sheet, I shall put it on the screen now, that shows you how to wire it. It involves some 100 ohm resistors. So I need one for each channel input, and what I'm going to do is I'm just going to put these resistor legs straight into the end of a crimp, and crimp that up, and then solder our input signal straight to that resistor. So I think it's these crimping pliers this time. Yep, that's good. So I want one for left and one for right. And then we need two more 100 ohm resistors, but with crimps on each end that go between ground and the inverting input. So I'm going to make the top sides ground, and then I can solder on to the relevant parts. So let's sort of fold it over like that and crimp it one part at a time, one on each end of that is my idea. So first things first, I'm going to cut them level. So that's the desired product there. One more time. Right, so back to the data sheet to look at the pinout of the audio connector, and then just populate it with those crimps. So that's pin 1, which is our ground there. Now pin 3 is the inverting input, which couples to ground via that 100 ohm resistor. So the other end of it goes into pin 3. And then channel 1's input is in pin 2, which isn't ideal, but we'll make it work. Okay. Pin 4 is input 2 shield, so that's the long length of that resistor there. Inverting input on channel 2 is on pin 6. Which is interestingly incorrectly marked invert 1 on the pin connector, but it says in the description it's channel 2, so there we go. Last but by no means least, channel 2 input itself and its 100 ohm resistor. And that is the finished product. A lot of under ohm resistors. Our ground is on these loops at the top there, and these are our two inputs. So the next thing to do is the 3D printed brackets. The Mark II has just come off the printer. The first one I've made, I've increased the height a little bit so the heatsink actually clears this loom down there. Where's the other part of it? There we go. And yeah, I've made this a lot fatter on this side, so that comes out there, and then we can screw that piece there onto the top of that block to hold the heatsink in place. So I can put it all in, slide the heatsink in, and then screw it up. rather than not being able to screw it up at all, or screwing it up immensely, in fact. But yeah, right, while I wait for those other couple of brackets to finish printing, I'm going to have a cup of tea, because you may notice by my perspiring brow that it's about 30 something degrees in here. We're having a bit of a hot spell here in the UK, and quite frankly, us Brits can't cope with it. Right, it's still stinking hot in here despite the fact the sun has now gone down. I have the 3D printers finished, and I've mounted these 4 brackets on the original screws. So the idea is that this is just going to sit in like that. Yeah, that's good. Butt up against there. And then these pieces, they're just a little angled piece with a hole in it ready to accept a sort of self-tapping screw. They're going to sit in like that and hold the heatsink in place. And yeah, pleased with that. That's just the job. Let's find some suitable screws. I don't think we need anything mad in there, just to hold those 2 in place. I think some of these sort of M3 by 12 self-tapping screws will be adequate. Ah. Damn it. Oh, where's my screw gone? Oh dear. Do the shake and vac, it'll come out.
Do the shake and vac and put the freshness back.
There it is. Oh. Yep, that's not going anywhere, is it? Plenty of clearance around everything. Plenty of room to let the heat escape. Not that there will be much, but yeah, I wish the heat was escaping from here. Whew. I've actually got the overhead light off at the moment because that's the worst bit of the heat in the workshop. And to that end, it's really too hot in here to work. I'm going to have to stop for this evening, I think, and come back to this first thing in the morning. But you can see how it's going to go now. I'm just going to pop that in, because that we've got to make right, which is our audio input. Because oh no, I thought that was going to be too short, but I think we're going to be okay with that. Excellent. Anyway, I'm going to come back to this tomorrow morning because it's just, I'm melting in here. Right, it's the following day. It's a little bit more pleasant in here today. Just got 25 degrees in here, which is much better. I've got a fan blowing there, trying to keep me cool. I have to say it's probably just blowing around warm air, but it's better than it was yesterday. So yesterday I just plugged in our little resistor balancing sort of thing there, so that's where my input lead's going to come from. I think I've just got enough wire on there, so that's good news. So first things first is I'm just going to strip these back and make those connections, so let's do that. First things first, I think I'm just going to try and tweak the grounds together so I can sort of make one ground position up, which will just help me get in there. I'm not quite sure I've got enough wire on the resistor legs. I should have left them a bit longer really, so I'm just going to solder in a resistor leg there I've just got a leg off an old resistor, off an old component, just to make my ground point up. I need a blob of blue tack just to hold that down. Tin that up nicely. I need to tin my resistors up. I'm just going to solder that across the top. That's got it. Cut off that excess there. Excellent. Okay, now the amplifier doesn't specify left or right channels, it just says channel 1 and channel 2, so I'm free to pick whatever wire I want to send anywhere really, and being as my left hand channel seems to be a little shorter, I'm going to make that the one that's nearest to me. Yeah, I don't appear to have much to play with here. Get my ground stripped. That is some weird insulation on that. It doesn't seem to want to cut. There we go. And same for the right hand channel. Let's get all that tinned up. Tin up my input 100 ohm resistor legs. I did think about this last night, so I was enjoying a glass of wine, and I do wonder if you could actually just take the inverting input down to ground without having the resistors in there, but let's do as the datasheet says. Why wouldn't we? I'm going to tack the ground on first, I think. There we go. Just trying to form my left channel lead a little. And there we go. So that's pretty straightforward. I'm hoping you're getting good pictures, because I haven't got the light on them. Like I say, I'm trying to keep the temperature down in here. Now these are all the various power supplies coming in, and in fact the speaker outputs. So I'm not going to use any of that. So I think it would be prudent just to put a little bit of heat shrink on all the end of there, just to stop. I mean, they're snipped flush with the insulation, but just in case there's any risk of a short circuit. And then if in, I don't know, 10 years time, somebody makes some magic 3D printer that we can make VFETs with, VFETs, sorry, then, you know, possibly we can revert this back to its standard form. But I'd like to leave it in a position where we can reverse that if needed. So yeah, I'm just going to get some heat shrink. Let's do that. On with a hot air gun, which is just what I need today. Okay, so that's made sort of safe. So I'm just going to, I'll put a zip tie around all that, just to keep it neat and out of the way a bit. There we go, it's not going anywhere. Right, we've still got to deal with the speaker output wiring, and again I just want to cut that off and insulate appropriately. In fact, can we just unwind it? We can. That's good. So that's my speakers now disconnected. Right, starting to get there. Next thing I think I'm going to do is add in my mains power, which is that socket there on my amplifier, and obviously we need to get power from the switch. So just need to work out which is the primary and which is the secondary. So switch is currently in the off position. Move around to continuity on the meter. Little sanity check. Lovely. So let's get on one side of here and we'll find out which is the primary of the switch. It's this side. Just check the other pole. Okay, so the primary of the switch, the input, which is always connected to the socket, is on the front here, and the output is on the rear. In this, that's white and that's grey, that wire. So the white is on the input, as is the purple, and the brown and grey are on the output. And I think what I'm going to do is route my wiring under here, come up here and just connect onto the output from the switch if I can. Where does it end up? Oh yeah, I can see the purple and the white coming from the IEC connector, and the grey and the brown are going, they're actually feeding up into here by the look of it. So that might be a convenient place actually. Let me see. So it's grey and brown. So the brown is possibly this lead. Okay. Yes, it is. Okay. Which is the input to the fuse and which is the output? Let me just see if I can tug on that wire. I suspect it's to the rear. It's going through on 110 to 40 volt switch there. Yeah. That's only going to be switching in the primary, isn't it? So, do we have a neutral anywhere? I shouldn't think it's fused, but maybe it is. That's unusual. I just need to, I think, consult the circuit diagram just to confirm that, because if it is live and neutral, then I can just come off there, and that would be a very easy point to pick up our power supply. The power supply is fused separately, so I haven't got to worry about any of that. Right, let me go and check the schematic. Well, I just looked at the schematic. It's precious little help. Obviously this amplifier was sold in many different markets, and this could be the AEP version. I can't find any indication on the back panel here of which version it is, but it doesn't quite refer to what we've got. So I think just to be safe, I am going to come off the back of this switch. So with that in mind, let's get my little mains harness here that I made the other day, and I'm going to route it underneath the heatsink, across the back and down the side here. So yeah, let's do that. Except for I said that was the mains, wasn't it? It's not. That's the DC output for putting more modules in there. Stupid boy. Let's take that back out then. It's actually that one there. Right. Makes it a bit easier to sort of route through though. And that's going to come up there and just attach like that, so I can use this little clip here, hold that in place, nice, and we'll come down like that. This amplifier is inrush protected, so hopefully that's not going to affect the longevity or lack thereof of my switch. Lovely. Right, so that's our mains power. All I've got left now is speakers, so I'm going to tidy up. There's a little bit of excess wire left on that post there. There we go, so we've got mains input, audio input, speaker outputs. The only thing is, of course, I don't actually know if the preamp in this thing works. I need to find a screw to go in there and then power up and test. Right, come back in a minute. Right, got mains in. I've got old faithful running into auxiliary 2. Got auxiliary 1 set on the front. Yeah, sensible volume. Let's turn that down. Let's find some license-free music. I think we can go with that one. And switch on. Yes. Tone controls are working. Balance is working. Oh, it's got some punch. My loudness is on. Yeah, we've got some crackly switchgear to deal with, but nothing that a dose of deoxit won't cure. Let me just pause there for a second. Preamp's dead quiet. Oh, I'm pleased as punch with that. Right, all that remains to do then is clean it up and put it on a bit of a soak test. But no, I'm pleased as punch with that. That's brilliant. The preset control, I'm not quite sure. This isn't making any difference. Ah, it's moving the detent on the volume control. There's a detent. The detent is where the preset control is. I'm pleased as punch with that. So, yeah, excellent news. Right, let's clean this front panel up and get a bit of deoxit in those controls. Pull the mains. I want a squib of deoxit. switches are right down in the bottom here. Let me put the light on temporarily. The switches you can see right in there, so work those back and forward a few times. Pots themselves seem to be pretty much crackle free. Let's try that again. I'll put the mains back in. Well, that'll be not so copyright friendly.
Lost in the amplifier's hum. Voices tangle in electric.
Yeah, it's much smoother now.
Wires twist and currents run. Broken notes speak into strings so loud.
Yeah, perfect.
So loud. Silent cry for sound. Unreleased. Take it to.
Nice. So now what remains to do is a physical clean-up. And there you have it, all cleaned up and looking very pretty indeed. Pity about these scratches on the top bit of the brushed aluminium face there. I wonder if I could maybe polish those out. Let me know in the comments below if you think that's possible. But yeah, pleased as punch with that. Sounding great. So all I've got to do now is sneak that into the lounge and hope Mrs. Doz doesn't notice. Anyway, thank you very much for watching. Click like, subscribe, do all that rubbish, and I'll see you really soon here on Doz's Television Workshop. Cheers now. Bye. Definitely time for a tidy up.
With a gentle hand, he brings them back in line. Every twist and turn makes the magic shine. And the crackle of the tubes amidst the dust, they play nostalgic tunes. Solder smoke and the faint aroma of time in each repair. An art that's so prime. Twist and spark, fix the picture, bring back color in the dark. Screens that buzz, it's magic on display. Old TVs revived in a brand new way. Circuit woes, but we're getting closer. Neon signs, they guide you to the door. Tubes and screens like you've never seen before. Pulses hum as sparks begin to fly. In this tiny shop, dreams are set too high. With a touch of love, your picture's clear and true. In Doz's hands, pixels flicker back to life and stand. Microchips and vintage heart in a world of screens playing their parts. Circuit boards with stories to untangle. Every wire a promise as an angle. With steady hands, as Dozzy bends the light through the lens, creating onyx nights. Oscillators creating sonic waves, bringing back the charm of retro days. Capacitors and resistors. In Dozzy's touch, there's no misfire. Transistors dance to the rhythm of repair through the magic fills the air. Voltage pulses, a tune's melodic run, a symphony of sparks where the work is never done.